In this video, we will look at wall bracing and wood framing according to the International Residential Code. Additionally, we will compare wall bracing to shear walls. Wall bracing is the application of structural elements on walls to increase the in-plane shear strength of the wall and to limit lateral drifts due to wind or seismic forces. The term in-plane refers to the direction parallel to the length of the wall. If a wall extends from east to west, the in-plane direction is the east-west direction. Lateral drift is the lateral displacement or deflection that takes place at the top of a story relative to the displacement at the base when a structure is exposed to seismic ground motions or wind forces. Please check out our other videos discussing the structural elements that are permitted to provide bracing in residential buildings designed according to the prescriptive provisions of the code. Wall bracing essentially consists of two functional elements in addition to the wall framing. First, the structural elements providing the in-plane stiffness. These structural elements include wood structural panels such as plywood and OSB, gypsum board sheathing, particle boards, cement plaster, and others. The second elements are the fasteners attaching the stiff element to the studs. The size and spacing of fasteners is an important component of the strength and stiffness of the braced wall. We have used the term stiffness extensively to describe wall bracing. Stiffness is a very important metric in the overall evaluation of elements resisting seismic loads. Stiffness is the ability of an element to resist displacements when a force is applied. A stud wall without any bracing elements has very little in-plane stiffness and strength. Therefore, if a relatively small force is applied to a stud wall without sheathing, the studs will deflect significantly. Large deflections cause damage to framing elements and wall finishes and may lead to building collapse. If a column or bearing wall carrying vertical loads leans on one side due to lateral loads, its capacity to support the vertical loads is compromised, and this may result in catastrophic consequences. To prevent this, the Residential Code requires and specifies bracing methods and minimum bracing amounts that will provide the necessary stiffness and strength to resist lateral loads at the appropriate hazard level. Let us now describe shear walls and distinguish them from braced walls. Just like braced walls, shear walls are also associated with the resistance of lateral loads. Shear walls and braced walls are wall systems that are intended to provide lateral strength and stiffness to buildings. The difference between the two lies in the framework of their design and the scope of possible types and areas of application. The term shear wall is normally used when referring to wall systems that are designed according to accepted engineering practice to resist lateral loads. This means that shear walls are designed under the responsible charge of a licensed design professional. Additionally, the term shear wall is used when referring to wood, masonry, steel, and concrete wall systems that are intended to provide lateral resistance. The requirements for the design of shear walls are provided in the building code along with other reference standards depending on the type of shear wall and the material used. Shear walls are used in all types of structures including residential and commercial construction. On the other hand, we have described braced walls as wood-framed wall systems that are intended to resist lateral loads. The Residential Code also uses the term braced wall panels when describing lateral force-resisting systems in the cold-formed steel wall framing section. The design of braced walls is nested within the prescriptive provisions provided in the Residential Code. The International Building Code also contains conventional construction provisions that provide for prescriptively designed braced walls. The point we are making here is that braced walls are prescriptively designed systems and their construction method as well as the scope of their use is statically locked within the boundaries of the prescriptive provisions. Therefore, the residential designer should use the term braced walls and avoid using the term shear wall when designing wall bracing according to the conventional construction provisions in the Residential Code. The term shear wall should only be used when referring to walls that are designed according to accepted engineering practice to resist lateral forces.